Well, in this episode of Finno-Greek machining, we are going to straighten our Hilma. Well, Hilma is actually Hilma Röhmheld, which is a German work-holding manufacturer. And I bought from eBay one of their vices, which was really affordable. It's in quite good condition, but now when I have been doing some work with it, I found out that it's a little bit tilted. Not in the direction you would expect, it's tilted sideways. In a distance of something like 70 millimeters, the deviation is already 500ths of a millimeter. That's way too much. It should be well within 100ths. So we are going to mill the vice bottom. There is something wrong with that one, because when I tighten it into the place, it binds the moving jaw a little bit. That also indicates that it's not straight from the bottom. So, it's just a simple milling job, you will see. First task is here I already started it. Let's go and watch what the heck I'm doing here. Okay, let's start. This is the rare occasion when this milling machine needs tramming, and not because of the accuracy of the surface, but I want to avoid any stripes there. So therefore this should be trammed perfectly with the table. And now what I have been doing here, this is now 0. There is a dial indicator which has the plunger at the bottom, so it's very easy for me to see this one. And then this is on free gear, and then when I move it around here, I should see the same 0 on both sides, and I do. The order of operations with this milling machine is really important. This is because this cylinder, which contains all these milling things, droops. So therefore you need to set up this direction first, because the drooping doesn't affect this direction. And after you are finished with that one, you lock up the cylinder in a place where this doesn't where we don't have any deviation here like now, and then we start doing the other direction. And now when you are doing this kind of things, you should be really sure that there is no chips or anything under there. So now we put it here. Now this is indicating 500ths of a millimeter under. That's bad actually. And this should be 500ths over. Yes, it is. So the nodding now is our culprit here. So, but luckily we can, I will now release this. The milling head. You can adjust the nodding. Well, 500ths. It's quite a lot actually. I moved this a little bit there so we don't. Okay, there you are. I don't want to loosen it too much, just a little bit, so that we can move it a little bit around. Then there is a locking mechanism which I can loosen this all together. I can index it first, and then so that I can see that this, okay, now you can see it's that's now locked. It's the indexing. Let's see. Well, 300s, 700s. Wow, that's quite a lot more. No. 300s at the other side, and this side is, well, it's a little bit more. So I disengage the indexing system now, because we shouldn't be using it. Well, this has an impact right away. It will actually, when I tighten this, it moves a little bit, because I disengage this. And then we take our tool of destruction and then we start knocking it. So this is like now there. I will see that this direction is still 0. Well, it's pretty damn near. It has moved. No, it hasn't. I just thought that it had moved. Well, it has moved the same amount, but not moved. Okay. Then I will... Of course I have locked the Z, because I don't want the Z to change when I'm knocking here. No, now this is now 0. Well, what do you see? It had an impact here. That's... I have to be really careful to have this in the correct... Okay, that's now the correct direction. Yeah, okay, now it's all right. Well, now this direction then. It's 500s. Which side? So we should knock it this way. There you are. And then, yeah, it's there. That was really easy. Didn't have any impact. Didn't move. Good. Did not move. Really good. This was easy. Easier than I thought it might be. So now it's 0. Then we check here. 0. And then there also 0. Yeah. Well, all 4 directions and of course all in between also 0. Yeah, okay. Now it's trammed. And it's tight. So, next step is to choose a suitable cutting blade for that one. And well, I'm going to use the material of the vise. I don't know how hard it is, but I'm going to use this one. And well, I think I will change the blades to something that gives a very good surface finish. I have some cermet tips for this one, so I can use those. Okay, let's change this. I will do this off the camera. Okay, I changed the tip here. And there it is. I only use one tip here, making this effectively a fly cutter. I don't want to use all 3 of them, because I'm probably running this very slowly and peeling off very faint layers of metal. So yeah, and this one is actually it's Cermet insert with quite a hefty radius. Well, this should make a good surface finish and also a very even surface. So now I just put it here and tighten it in place. Hopefully not affecting my tramming here. Well, now there you are. And well, then we need to attach the vise here. Well, I have these two parallels here, and now we are going to need all the travel of this milling machine. So I start by putting this on the really far edge here. Oh yeah. And that's about as far as I dare to go. Let's put some oil into there. Onto the vase I have this oiling system which I can squirt oil into there. Oh yeah, a nice squirt comes from everywhere, and the same thing for the other way as well. Yeah. Okay, and then that's it. Now what we need is the vise. And here it is. These are the surfaces I am going to lean onto. So I will have parallels here under, like that. Ooh, this is heavy. I have to be careful not to bang anything around here. Oh man. Okay, now we are there. So I move this in a place where we can reach a little bit past that point. That's our first. I think that is where we can go. A little bit more to that direction. Yes, okay, there you are. And well, I can attach it from here under, which is really good, because now I can pull it down from here. So that clamp will not be on the way. I will also try to put it in the middle of the travel here. Okay, like that. We cannot reach at the very far end from that direction because, we have to move the workpiece at some point, and this might cause some trouble, but well, I doubt it. Okay, I think we are good to go with this side. I'm just wondering, well, that's a little bit, we need to put it exactly on the middle of the table, so then we are good here. Well, now, I don't know what's wrong with this one, but I can see that we have some strange things at this side here. Oh yeah, okay. Well, I don't think this is really, and here we have, you don't see them, but I see really bad. Well, okay. Then I just clamp it here and clamp it from the back. And then we are, I think, ready to, let's see about the, I want to see if we can mill it all the way. We should be able the widest point as well. Okay, this is good. And then this one too. Yes, we can reach the whole surface in one setup. And this is actually, this surface here at that point is the most important. This should be really flat. The tail of this vise, actually I wouldn't need to mill it at all, but well, because it doesn't touch the table when I have this in the milling machine the way I would like it to be there. So now we start from this point, and then I'll do as far as it can go. Let's see, by the way. How far can we go here? And well, at first I'm going to peel 0.2 millimeters from this. Oh, we can go quite far actually. Man, almost at the end. This far we can go. Very good. Okay. Oh yeah, okay. Good. That's good. Yeah. So there is just a little bit that is needed. I need to move this workpiece, but it shouldn't be problematic at all. So, okay. Well, and also when I'm now clamping this, I should take care. Okay, it's still, by the way, we need to go this way a little bit. Okay. I need to take care not to clamp it too much force, because this clamp is not over the parallel. So when it's not over it, it will try to bend the whole thing. Well, but it will. So I need to be very careful when clamping this one. Well, and yeah. Okay, next step, clamping. Okay, now the workpiece is clamped here, and I also have now the insert in there. This is a very large radius insert, should give a very good surface finish. And then I will do, well, I said 0.2 millimeters, but I will actually do 0.1 millimeter first and see if it cleans the whole surface here. If it doesn't, then we can always make another pass. And yeah, and now I have already touched it, so it's on 0, so the next step is to raise the table 0.1 millimeters. And there we go. And now, as I measured the tram by locking the Z-axis, so I need to lock it. So now, well, I think, well, okay, this is now running 400 revolutions per minute. And then the feed is 25 millimeters per minute. So it's pretty slow. I will see what kind of surface finish will be from that. It should be really good. I will be using a small amount of cutting oil here on the surface, just a little bit, like this. It helps to keep the insert in alive. It doesn't need a lot of this, just the tiniest amount. So now it's spread all over the place like that, and then I think we can start doing the first pass. Well, it certainly looks like a good surface. Yeah, it looks and feels also very good. Well, take these chips away from here. Chips. Oh yeah, okay. So now we know that the tramming is alright because it doesn't scratch too much. It scratches a tiniest amount on the backside, but not much. So yeah, okay, now that was the first pass. And now I will turn this into a position where it doesn't cut, so we can move the table to starting position. Oh yeah. Well, it's a long way to Tipperary. Wow, really long. Okay, now I will see that we are far enough. There you are. And then we, one more time, wipe off that too. And of course the insert looks really good at the moment. Okay. And then we advance the Y. How much? Half of the cutter width. About this much, I believe. Lock the Y again. And then spread the cutting oil here. Well, this will be now we will see if our nodding was alright. So I will see how much does it scratch the backside here. It shouldn't scratch too much. It might scratch something, but not too much. So now we go. Next thing. Okay, now, and it was locked, yeah. cut was totally different. It cut way more than it has cut so far. And that's good news, because now we are going to have this done in one go. So we don't need to do this multiple times. And you can see there are more scratches also here. Still you don't feel those lines. They are just visible, but you don't really feel them. Now, where is the bit? There you go. Yep. Last pass. Well, the surface finish changes. Here it's really good, here it's really bad. So this means that the insert got worn about at this place, and there were really high spots somewhere in there. And well, what I will now do, I will actually plane it one more time, but this time only 500s, and I will step over more. So yeah, and I will index that insert. It's well, yeah, that I don't show on camera. This pushes the limits not only for the envelope of this milling machine, but also the memory card of this camera. Okay. Well, now this is how it looks now. There are some stripes here, but you actually cannot feel them. They are just an optical illusion, so to say, because of the way the cutting tool was doing its job. And when I look into the surface, it's a crisscross pattern here, meaning that it was very straight, the cutting tool itself. So, well, yeah, okay. This is why I need to tram it. But now, let's see. We need to... well, we don't need. But I have already draw filed these corners so that we don't have burr in them. And now I will do just a very slight, emery papering on the surface to make it, if there are any anomalies, they will be now taken off. This is 180 grit, sandpaper, and in my orbital sander, and away we go. Yeah, that's it. Not more. Yeah. It didn't make any difference Well, it did something for the surface, but not a lot. Well, it's okay. Now I just put this into my milling machine and measure it. That's the next step. Okay, now, how did we do? I have now placed it here. This is loose at the moment. I haven't tightened it, and well, there was a difference right away when I put this on the table. It didn't make any scratching sounds, just that wonderful sizzling, which tells that the surfaces are really clean and that there are no really high spots anywhere. Earlier it was like scratching. But now, well, let's see. So now I have zeroed my dial indicator here. It's touching, as you can see. And when I move it to the other side, there is 1/100th of a millimeter difference here. Well, why is this? Okay. First of all, this milling machine is 67 years old. Oh, well, that's one reason. But then there is one thing that caused this. This was the side I milled first, and then I progressed to that side. So this is a little bit higher. It means that it didn't take as much from that side than this side. This is because the bit wore out. It really, this material is quite tough. I can tell from the chips that it's nothing soft. Well, yeah, okay, very good. But still, without, what's this device called? A grinder? Plane grinder? Grinding machine? It's very hard to get more accurate than this. And then the other direction, which is, this was the X direction. Now if I see how it looks in this direction, so there is absolutely no deviation here. This tells me that the theory of the bit wearing out is probably correct. Then one more thing, if I now tighten these, if it would be somehow a little bit crooked, it should make a difference. It didn't. Not a lot anyway. So now it's fully tightened, this side. Earlier this had a habit of changing when I tightened it. So it was really crooked on the bottom. And now when I tighten these two, so, and it will, because of this, because it's now really straight from the bottom, it will actually make a better grip on the table. Yeah, there you are. So 1/100th of a millimeter deviation. Well, that's about the accuracy of this machine. Well, I would have, it would have been better if it would have been a little bit more accurate. But with this one I can live with. Earlier it was like 0.1 millimeters deviation between these two. And I don't understand how that would actually be possible. And it also made it so when I tightened it to the table, the slide, the moving jaw started to bite. Yeah, of course, because it was deforming the thing. Okay, so now I think we are good to go with this one. Yeah. Okay, so now, it's straight enough. Well, 1/100 of a millimeter on a track of 70 millimeters. Well, actually more because it's the pedestal, so that makes it tilted. So, well, I'm happy with that one. If I really want to make a straight piece, then I need to turn it, not just turn it like this, I need to turn it around like this when turning it in the vise to get it straight. That way I can compensate for this little deviation what is in that direction. The other direction is really good, so I think I can make cubes with this one now, accurate cubes. So, how did I detect this problem was, wait a minute. I was making a new tool holder for my lathe. Oh, this is sharp. Oh, man. Tool holder for my lathe, and this is tool steel, and it's really like a knife. So, and this became tapered. The other end is 0.1 millimeters thicker than the other end. And I'm really sure I don't make that kind of mistakes anymore. So, I had the parallels under, etc. So, and knocking the piece and whatever. And then I did it again, and then I started to measure the vise and found out this problem. It's funny that I didn't notice it earlier, because I measured it from the jaws, and the jaws are really perpendicular. Yes, and I could tram it really well, but I didn't measure the vase, the bottom. And this is something I rely on when I put a workpiece onto the vise, so I rely on the vase so that it's like level. Man, and that one was giving me a lot of trouble. But now it's over. It's done. Now, well, it's not totally over. I still have this 0.1 of a millimeter deviation there, but it's 1/10 of what it used to be. I can live with that one. So, in the next episode we will start welding. Hopefully you can wait till that time. Till then, bye!